Good morning, everybody from Hamburg. So very happy to be here. Stefan, thanks for inviting us today. So we're going to give you a tech session about the Snyk platform, the solutions we have today. So very happy to be here, and let's start off. So the people you're going to see today and listen to is Paul, who's our partner solutions engineer. He will give you the platform demo and will answer all your technical questions. My name is Carl. I'm a channel manager within Snyk, so I take care of our most important strategic partners in some regions. So just to set the scene, right? So it will be 2-3 slides before we actually jump into the platform. I would like to emphasize what Snyk does. So if we are an IT security company, but if you think in IT security, that can mean actually a lot of things. So on the left side, if you're thinking about IT infrastructure security, there is companies doing this. If you want to make your devices, your endpoints secure, there's also companies doing this. Identity management, there is also other companies doing this. So then you might think like all your IT is secure, but you haven't thought about the software developers. And this is where we approach with Snyk, right? So we want to make software developers coding and writing applications securely and fast. So this is our go-to-market. This is where we got founded 8 years ago, and this is what Snyk does. Quick overview about the platform and the solutions we provide. So like that purple boxes you see on the left, this is our 4 solutions. So we're making sure, first of all, that your code, like your source code you're writing, is going to be written in a secure way. So that's SAST we're doing. The second solution we offer is your open source dependencies, SCA. That's written in a secure and in a fast way. Then we also look at your container files, like your Kubernetes clusters, for example, but we also make sure that your infrastructure is code. Images, your HashiCorp environment, your Helm charts are written in a secure and in a safe way. So this is the solutions we provide. Altogether, it's our platform. On the right side, you see some of our ecosystem partners we partner with when it comes to runtime. For example, we do that with Stackhawk, have a very tight integration into the Atlassian world. ServiceNow, HashiCorp. There's also partners, but also investors into Snyk. So that's a broad overview about Snyk, what we're doing. And now I'm gonna hand over to Paul, who will give you an insight on what he will just tell you later when he's doing the platform demo, that you find yourself in the platform.
Excellent. Can I share my screen then, Carl?
You can do this. So I stop sharing if I find that thing.
You can see my screen now, everybody. Yep, excellent.
Yes.
Okay, so as Carl says, we're a developer-first application security platform, helping developers actually when they're building applications to make the right security decisions. And here I've kind of got a developer's workflow, how they'd work in a team, perhaps on an existing code base, creating new functionality. So over in the left, we've got the code already stored in the SCM. This is where you can do your first scans with Snyk. And often when we're speaking to customers, this will be the first place that they integrate with. And here, as Carl was saying, we can do the code, the open source, the containers, and the IAC scans to look at any vulnerabilities at that stage. So when a developer's working, they'll check out that code, that Git repository to their local machine. And that's where Snyk integrates with the IDE as well. As they're building their new feature, fixing a bug, or moving that application forward, again, we can scan all 4 of those different layers in the IDE. When the developers finish that work, they'll then create a pull request or a merge request, dependent on your nomenclature and the tools you're using. And again, Snyk can check at that space, but here it's a slightly different check. We're checking the delta. What's changed, and has the developer added any new vulnerabilities or license compliance issues at this stage? And this really prevents new vulnerabilities entering the code base as well. Often when we do a pull request or merge request, there's then an automated build that gets kicked off in the CI/CD. And again, Snyk can help in all 4 of those different layers there. And what this means is we can automatically fail builds if we find certain vulnerabilities or certain levels of vulnerability, for instance, critical, during a CI/CD build. Once that CI or CD build has completed, some artifacts get created. And we can integrate into the artifact registries or the container registries again to do that scanning there. And finally, we can look at those live cloud environments. What's in there? Is it vulnerable in terms of its composition? And everything that we try and do in Snyk, signified by this top arrow here, is all about what can the developer do to fix it. So if we identify vulnerabilities in a live cloud environment, what needs to change in the Terraform in order to fix it? We don't want people practicing click ops where they update a container on live or change something on live where it no longer is represented by the Terraform. We want the developers to fix it at its root cause, and that's what Snyk's all about doing. Okay, so let me open up the platform and show you what we have. Okay.
Any questions from the audience yet? So I see
Florian.
One hand, Florian.
Hi. We had the pleasure to meet on the ITSA. I have one question because I saw it multiple times, and because you said in the beginning you're able to scan or to check Helm templates or Helm files.
Yes.
Is this after rendering the files, or is it in the Helm construct itself? So do you first render it?
We can look at both, but if obviously there's logic or things that need to be rendered out, then we won't be able to look at those things until it's completed. It's the same with Terraform. We can look at your Terraform files, but also when they're run, we can look at the Terraform plan as well.
Okay.
Now, one thing we can't do is look at CDK, but we can look at the resulting cloud formation scripts. But that CDK is perhaps something that we're looking at for the future as well. So if there are kind of logic kind of things, and we see this in Gradle files as well, obviously we can't actually run that file because there may be some local parts to it which we don't understand. So looking at that rendered file always helps as well.
Okay. And are there any plans to add customize as well?
Not at the moment, no.
Okay.
Do you use that quite heavily internally?
Yes, because on the KubeCon in NA, there was a really embarrassing presentation from the Helm guys, and yeah, customize is already built in kubectl, and yeah, we use that to create all the files. Okay,
I'll take that as an action to speak to the team and get back to you on that one then, Florian, in terms of what our plans are there.
Thank you.
Excellent, excellent. Okay, you can all see my user interface, and this is kind of where you log into the platform in order to look at the projects that you're interested in. But just for a quick orientation, on the left-hand side, you can organize your projects or the projects that you're a member of by these groups. And within the group, you have a number of organizations. These could be individual apps or any logical grouping you decide. And that can be built manually or based off kind of tags that you've got within your SSO within your group as well. So all of this can be defined from the top level IT, and that means developers are just seeing what they need to see first. Though the first place you go to is over to the integrations page. This is where you set Snyk up to start looking at all the tools that you're using within your DevOps pipeline. So your source control tools, your cloud platforms, container registries, orchestrators, CI/CD pipelines, ID plugins. There's quite a huge list, so we're not going to go through all of them at the moment. But as I say, when you're first speaking to customers, usually they'll have existing code. They won't be starting from scratch. So one of the best places to integrate is in that source control tool. So here you can see I've got a few configured, and I can click on one of them now to start doing that integration or to start pulling some code in. So here I'm using the GitHub one. You can see I've got a number of organizations within there, and I can scan one of my projects, and I'm going to use one called the Node.js Goof, which is an intentionally vulnerable app. So you'll see a lot of vulnerabilities, but don't worry, don't publish this application on any live infrastructure. And what we do, we go over using the API to look at all 4 of those different layers that we spoke about before. And we come back once that has scanned. You'll see this was tested a while ago, but it is re-importing the project now. I don't expect many new vulnerabilities, so we can look at this snapshot here. And we've got a scan around all 4 of those different layers. We've done a code analysis scan, which is static analysis. We've done a package.json scan, which is SCA. We've looked at the deployment.yaml and a Docker file, and we can see the number of vulnerabilities we found at each of those layers there. Now, quite uncharacteristically, the Docker file's actually got no vulnerabilities, so that's good. I've not seen many containers that don't have any. So here we go. The first thing a developer would probably want to do is look at the code that they are writing and to see why that's vulnerable. So if I open up my static analysis scan on the UI, you'll see what we do is we organize things by the Snyk priority score here. And that's not just based off the CWE or the type of vulnerability, but also because it's found in multiple sources, and this file is in multiple code flows as well. So it could be there's multiple ways to actually call this code, meaning multiple vectors of attack. And that's why we kind of push this one higher. And as you can see, it's a NoSQL injection. And I might in a minute ask the audience if they can see this vulnerability. It is a very simple one, so I expect you can. And we can see we've got the NoSQL injection. It tells us the line of code where the vulnerability is, but I can also go into the full details and have a look at the data flow or taint flow analysis. So here's where we actually step through this vulnerability from its point where it's ingested from the request. As you can see, it's all pretty much on the same line, so quite a simple one. Can anyone see the problem here? Perhaps no one wants to speak, actually. It's quite early on a Friday morning. But what the problem is we're receiving a request body username from the user input. This will be from the front end or the web interface, and we're inputting that directly into the find. Now, the problem here is we're using Mongoose to actually find that user. And we're not specifying that this has to be a string. We're expecting the user to be nice. But what a user can actually do is inject some JSON here, some logic that will then get interpreted so that we can always find a user. For instance, where password doesn't equal password, we can pass in there. So actually, we're showing the developer that they've got a problem. But the next phase is, especially in a world where we've got more and more junior programs launching and more teams perhaps working disparate to each other, we want to show developers examples of how other people have fixed these problems as well. So what we actually do is we give them 3 good examples of ways developers have fixed this problem before. And here you can see we're actually checking whether or not it's a string. And if it's not a string, then we're not passing it into the find. And that might be something that we want to do here. Another alternative would be actually to cast it to a string as well. So the developers got this kind of information here directly on their machine and then can go back and understand if I cast this to a string or check if it's a string before I do the find, I can remove that NoSQL injection problem. So there we've talked about the 2 first things that you're seeing here. Number 1 is prioritization. Number 2 is remediation, helping with that remediation. And then number 3, especially again for those junior developers, is the education. Here we can see if I don't really understand the mechanism of NoSQL injection or want some more education around that topic, we also give practical contextual lessons about these types of vulnerabilities. So here I've got NoSQL injection attack. I can go down and actually press start and go through a practical example, thinking like a hacker, an adversary rather than just a programmer, to understand more about this type of vulnerability. And I understand the mechanism down here, and then I can go and fix the code and prove it's no longer hackable as well, with a small quiz at the end. So Snyk's helping with that contextual education. It's not something you do up front, but as you find these vulnerabilities in your code, we're helping you address those as well. What we can also do as part of this is give you learning paths as well. And these learning paths, your manager can see how well you're doing. You can track your own progress through them as well, such as the OWASP Top 10 here, where we can go down and take a lesson down each of the most common vulnerabilities that you're going to find within code. Now, we want developers to get better. That's one of the parts of the Snyk platform. So this education is something that we're only going to increase on and build as we go forward. But needless to say, we can go and fix this issue now. And this is what the developers seeing from that kind of space within the user interface. But this is exactly the same as they'd see using the Snyk plugin on something like Visual Studio Code as well. If I can close these up, you can see we're looking at open source, code security, configuration issues, and code quality issues. So if I look at the code security, I'll see the same NoSQL injection issue here identified in the UI. And we can see we're seeing the same information there, which lines or flows it was implemented by, and some examples of how other people have fixed it as well. Just exactly that same information. And you can see here, we've even got the link to the lesson. So developers don't have to use the Snyk interface. We always want to meet the developers where they are working anyway. So that's why our tools leverage the Snyk backend to display that information and help developers make the right decisions. This means actually the developer could fix it before they've even made that commit as well. Okay, so that's what we're doing in that static analysis world, looking at the code before it's been compiled, inferencing based off things like the language, and also things like the framework used as well, which we understand, therefore giving developers that understanding of the code and helping them fix it. The next stage you probably want to look at, if we go back to the projects, is the open source that you're including. And again, this is available in the UI and within the IDEs. So if I go to my package.json now, again, we'll see the vulnerabilities that have been introduced. Here I've got one called arbitrary file write with archive extraction. And we can see very simply, it's told me the problem is found in 047 and it's fixed in 0411. And if I can see here, I can understand more about the vulnerability and I can create a pull request to fix it. If I don't want to fix it, I can create a JIRA issue. You can see I've already created a JIRA issue for this one myself, so I know there's no duplicates being created. Now, the important thing here is ADM-zip 0411 is not the latest version of ADM-zip. What we're trying to do is use the minimum increment in order to remove the vulnerability. Where possible, we don't want to have to update packages a major semantic version because that often requires a rewrite. And you'll see in the next screen when I show you, actually what we try and do is show developers when that might occur. So if I wanted to fix this vulnerability, I would click fix the vulnerability. We'd go to this screen where we can craft further what that pull request includes. And we can see it's just got this one item ticked at the moment. And if I go through and create that pull request, it'll update in this sense the package JSON and the package lock file. Anything here with a warning signal means we're going to have to update a major semantic version. So we know probably we want to do this on a test branch, perhaps as an atomic commit, so that we can understand the changes and perhaps change that interfacing code as well. But if I wanted to fix this one, I'd scroll down to the, in this case, a huge list of vulnerabilities because of the application we're using, and click open this fix full request. I'm not going to do that because I kind of just wanted to show you something a little more important that Snyk's helping with here. And that's we build the full SBOM and understand the dependencies in the full tree. So if we're looking here at the dependency tree for this application, what we can see is that body parser which we're using at 190 contains no vulnerabilities, but one of its transitive libraries does actually have a vulnerability QS. So we know in this particular framework, NPM, we can ourselves update QS because that's only defined by body parser itself. What we'd have to do is update body parser to a different version that uses an unvulnerable version of QS. And quite often, if you're using tools like Dependabot, they won't give you that kind of insight or help you update QS. They will just tell you QS is a problem. If I go back to the issues now and look for that QS issue, you'll see we've got more information now. So it's a high vulnerability, prototype poisoning. And it's telling us we've found that vulnerability in 3 different paths. The first path is in that body parser, that one that we just looked at, and that can be fixed by updating body parser from 190 to 119.2. But we've also found it used in Express as well. We need to update Express from 4.12.4 to 4.17.3. Now, finally, we've found it in another application or another library called TAP. The problem here is the people at TAP have not yet updated or fixed this problem. So there's nothing that we can do at this stage. Now, this might be a case to perhaps create a JIRA issue and say, TAP isn't fixed. We might want to contribute to the TAP open source project in order to help them update it, or we might want to fork TAP ourselves in order to use a different version. The decisions there need to be made. But if I go and open this pull request now, we'll fix the first 2 vulnerabilities by updating body parser and Express, therefore removing that vulnerability. Then we can decide what to do in terms of TAP as well. So although we're not able to fix all 3, at least you have visibility of those 3 different paths and can remove 2 of them quite quickly. Incidentally, what you'll also see, if you don't understand prototype poisoning, again, we can go and take a lesson, understand what that is in prototypical languages, how we can stop that type of vulnerability, and how it's usually implemented when we're cloning objects with things like underscore or other libraries as well. Again, it's a practical lesson. You can learn all about it using examples and become an expert through Snyk's training program. And essentially, that's what we're doing in the open source. Now, yes, we can create that pull request and fix it, but Snyk also does this work automatically as well. We have a mode where we can create a number of pull requests every day that fix vulnerabilities. And then you, your merge manager or your branch manager will look at those pull requests that Snyk creates automatically, can merge them in and try and run the build to see whether there's any regressions. And again, that just helps with the scale of what we're doing in terms of security efforts. And all of this can be kind of configured within the settings. If I go to my settings, integrations, for instance, for GitHub, you'll see there's a number of things that we can do. Pull requests, we can open automatic pull requests. We can say, is it for new vulnerabilities or existing vulnerabilities in the backlog? We can decide the motion. And really, everything that we decide here, we're looking at the customer's kind of DevOps maturity or DevSecOps maturity. What would this do if we turned it on? Would it slow the development team down? Or would it help them be more secure? At what stage should we turn it on as well? Should we remove all critical and high first? And then start turning some of these extra features on to protect that code base as we go down. So lots of different configurations that we work with customers to ensure that we don't go in day one, turn everything off, stop all development because there's vulnerabilities everywhere. Then everybody hates the tool and tries to find their way around the tool. What we want to do is work with the teams to ensure that it's a steady process of getting better at security, understanding the procedures and turning on more and more of these protections. Therefore, we can actually scale that operation. Okay, any questions on the open source side of things before we have a look at the next level? Stefan.
Yes, one question regarding the quality gates and build breakers. I think on the one side, you can introduce some quality gates here on how many criticals or high vulnerabilities you can have here. Okay. And my other question is, since Snyk is running besides the actual pipeline, so the analysis is done besides it, can I break the build when, for example, my main branch has vulnerabilities or something like that? How is it integrated in my build pipeline?
Excellent, good question. Let me. I've not got this in the right window for some reason. Apologies. Where's that gone? Okay, so there's a number of ways, and let me just quickly show you of the CI/CD tools that we do integrate with. So there's lots of integrations that we've got built already within the CI/CD template. If you don't see your particular integration here, what we can do is use the command line interface. And we do have quite a lot of YAMLs already built that you can kind of push into any of your CI/CD platforms. Essentially, what we're doing underneath though is always, in fact, let me clear that. What we're doing is basically doing a Snyk test. Now, this Snyk test can either be open source, it can be the code, infrastructure as code, or looking at the container. When we're scanning the container, it can either be the container image or the Docker file. Essentially, what we're doing in the background is we're doing the scan using the CLI, and we're looking at the exit code for that CLI as well. Now, the exit code can say only fail if there's a critical vulnerability, only fail if there's high or above, or fail for any vulnerability. So really, when we're crafting these scans within the CI/CD, what we do is we craft why we should fail as well. Now, added to that, we can actually go one level further and start outputting all of the scans as JSON, introspect that JSON, and see if there's certain CWEs or CVEs failed that build as well. Now, there's really quite a lot of configuration that we can do within there to make sure that, number one, it's useful to the customer, and number two, we're not failing builds for erroneous reasons. So when we're speaking to the customers, we first understand what do we need to do. We'd never go in and just stop pipelines. Everything is available to us at all those 4 different layers. So I can even do a Snyk code test on my local machine. That does a static analysis that you've seen within the UI or the IDE. And again, we're just outputting some simple information here. It's not meant to be used perhaps by the developers to fix the vulnerabilities. That's where they'd use the IDE or the IDE or the web interface. But what we are doing is we're using the exit codes here in order to fail these vulnerabilities. So we can just say if there's any high or critical, don't pass in each of those layers in the CI/CD, and therefore automatically make sure no vulnerabilities go live. Now, it's important to do that in the CI/CD because perhaps we're doing 10 of these a day by lots of different teams on lots of different applications or microservices as well. So we want to have perhaps CI/CDs that are related just to a project as well. And that's why when we're looking at when we run this particular command line interface, what we are looking at is the certain project that's involved as well. So you can have different policies applied to different projects. So it may be that on one policy, you want anything to do with a CWE 400 to automatically be critical because that's a Java front-end web interface. So you would have a security policy attached to that project, and that CI/CD scan would look at that policy as well. Now, that's a bit deeper into the configuration, but what we want to make sure, as I say, is there's no false positives or something seen as false positives. I mean, even the term false positives, we have to define it before we use it, of course, and make sure that everything is useful as we go through that CI/CD. But yeah, we can certainly help you set up some example CI/CDs to see how best to use it within your environment as well. Florian.
Hi, because you were talking about how to integrate it into pipelines.
Yep.
How, or do you have a concept to use it with GitOps? Because if you use the GitOps approach, you don't have the traditional pipelines anymore. For example, when we build our application, we have the Java build, and inside of the Java build and the Maven, we have everything. We have SonarQube, we have BMD, we have also the build inside. We don't build the artifact and then put it into a Docker container. we build with Maven the Docker container, and as soon as it is built, the pipeline will just add the tag into another repository, and then everything runs automatically. So there is not much possibility to interact with these kind of pipelines besides the artifact build step, the compile step. So are there also like Maven plugins for Snyk, or is it just this a CLI tool?
It's just a CLI tool, but adding extra steps to that, perhaps before it goes to that Maven build, is how you'd get around that. So are you doing this in GitHub? Is it in Actions? Is that how you're running these?
GitLab.
GitLab.
It's just
okay.
the build is triggered, and as soon as we got the tag or the image tag, the new one, it's promoted to another repository.
Yeah, so you could add another step within that, or you could actually check it on the side. So allow it to go through, but then trigger another build which checks it, and then you can pull it down if you find those vulnerabilities there as well. Because the artifacts are there that you can scan. So you'd either do that by adding extra steps in that GitLab task, or doing something concurrently on another run as well.
Okay, because we try to do it this way to remove to remove the extra building steps, because like you said, you would promote a vulnerable image first and then test it, but then someone had the possibility to put it into the system or into a stage, and that's why we wanted to prevent it. So this will be a little bit tricky. Okay, thank you.
Yeah, it is, and then you've got to decide really, okay, if I do put a vulnerability live, but it's there for 5 minutes, what's the real risk compared to not putting the vulnerability up at all? And then that's your decision. You know, if you actually cannot risk putting vulnerabilities live and need to remove them, then that step has to go in there initially. But if you're testing and within 5 minutes you recognize something and can fix it and push the next one up, again, that real risk that's being given is quite small. So you'd have to decide on that risk profile and whether or not that's something that you can live with when building those tools. Excellent. Okay, so shall we go to the next level? I guess one of the next things you want to look at is that kind of Docker file. In fact, can I just see if I've got a Docker file with any vulnerabilities? Because showing one with none is probably not useful. So what's interesting about scanning the Docker file before you actually build the image is that, again, the developer gets that view of what's going on and what they can do to fix it. Now, quite often when we're speaking to developers, they don't decide on their own Docker containers. They generally don't update them as well. That might come from the DevOps team or the infrastructure team, and they use these golden images which are perhaps given to them. But what they might do is they might change the Docker file to add a new library in, or update the base image when they see vulnerabilities. And what we're giving the developer here is some real great oversight really into the images that they're using, the vulnerabilities that they're bringing in. Here you can see I'm not node 12 Alpine. I've got one critical there. But here I can say, actually, if I do a major upgrade to node 21, if your application supports it, of course, I can remove that critical and just go down to 2 vulnerabilities. There's also alternative images that we can use as well, but all of these really have got more vulnerabilities. So what would the developer do there? Well, they might go for an upgrade if their application supports it. And here again, I can open that pull request. But another thing that they could do is perhaps harden that container that they've got here. Understand what that critical vulnerability is. It comes from zlib. I can actually perhaps upgrade, apt-get upgrade that existing library by adding that line into my Docker file, or I could decide actually I don't use that library, so I'll remove it as well. So there's a number of things that you can do, but understanding, especially from the developer's point of view, that they can affect the infrastructure as well. If only they're given the right information, they can be part of the security effort. Now, depends on how you work. You might just say to create a JIRA issue and say to the infrastructure team, please fix this container. give us a new golden image because it's got a critical vulnerability, or you might have that impact yourself and be able to change that. But understanding, again, what's been loaded into this by looking at the SBOM, you can start to say, which actual applications do I need in this? And the ones with the vulnerability I might not need at all, and can start hardening the container and removing all of that software that I don't need on the container anyway. Now, incidentally, we're also looking at the container images, whether they're built in CI/CD, we can scan them there, or whether they're on the container registry, we can also scan there as well. But this is really that developer kind of information, helping them understand what they're loading applications onto and let them do that initial kind of investigation or fix as they're running through. So again, another really useful tool, and it just looks like a small table, but you can imagine the amount of time that saves developers. Having to look for different versions, having to decide what to update, everything's given there. With one simple click, they can update that container, perhaps again on a test branch to understand if their application is supported on a Node 21 container. And again, they can make that decision and look at the individual vulnerabilities. Another great thing that Snyk brings to the developers there. Now, finally, we've got everything secure. Imagine we've fixed all these vulnerabilities. That final stage we want to look at is the infrastructure as code. And here I've got a deployment.yaml, but it'd be a similar way of working for all of our infrastructure as code tools. In the deployment.yaml, what we're looking at is the policy that's been set for this project or this group of projects. We're finding where there's vulnerable infrastructure as code. So this container does not drop all default capabilities. Again, we're showing the developer the issue, the impact, and the resolution. Something here that we've not got, you'll notice, is fix this with a pull request, but that might be coming down the line. But what I can see is I can fix this by security context capabilities drop. And again, I can learn about this. If I'm new to infrastructure, perhaps as an application developer, I can go down and take this lesson, understand what the problem is, hack a container, and then understand how to fix it going down as well. So that education is all important to Snyk, as I mentioned, and we can go and fix these problems. Now, incidentally, again, that's available in the IDE. If I look at my configuration issues, I can see that same issue there before I've even made the commit, helping the developer actually fix that problem. But one thing that's really important in Snyk, and that you're not going to find in any other tools at the moment, is the single policy agent. So if I set my policy for AWS, Azure, GCP, or plain vanilla Kubernetes, each of these items is looked at in terms of the project context. If I change one of these items, for instance, if I go medium to high here, then the developers on their local machine, the next time they scan, will look at this new, changed, updated policy. The next scan in the web interface will look at that new changed policy. Now imagine if we had a CI/CD run and it said, don't let anything high through. Well, that next CI/CD run would also fail because now we've changed our policy to change this medium to high as well. So because everything's looking at that same policy throughout this whole pipeline, once I, as a security engineer or DevOps engineer, change that policy, every scan's looking at that policy. So we can stop things across the multiple ways. Even that next scan of the cloud environment will also look at that policy. So even if we've not changed our cloud environment, but the policy's changed, the next scan will show us we're now vulnerable or we're non-compliant with the new policy. And that means the developer would go back, change the Terraform, go through CI/CD, and make the infrastructure that's live fit with that policy as well. So that's a really powerful tool. And you're not going to find this in any other place. And it helps that either non-compliant infrastructure or non-managed infrastructure be detected throughout the system as well. Okay, there was another thing I really wanted to show you. And it's in terms of where Snyk's going in that ASPM world as well. So what we also have now is something called insights. And insights is really trying to tell developers, yes, you've got a lot of vulnerabilities. And sometimes there's something called analysis paralysis, where you've got so many vulnerabilities, you don't know where to kind of attack first or what to fix first. So what Snyk's doing now in this whole app risk world is starting to look at vulnerabilities a little deeper. So rather than, in this instance here, we've got 110,000 open issues. Now, of those open issues, Snyk knows, because of the way we've set up our projects, that only 18,000, I say only, but anyway, only 18,000 of these vulnerabilities are detected on a container operating system. Now, that could be an image. It doesn't mean it's deployed. It means we're actually using some of these vulnerabilities on container images. But what that immediately does is allow us to filter down that 110,000 to a lot smaller. We can then detect which of those container images is actually deployed. This is on an environment. So now we're down to 2,000 vulnerabilities that we really need to attack first. And then finally, of these deployed container images, which ones have open ingress, a pod that's got open ingress on a Kubernetes cluster? And again, we're down to 1,000. And here, as we filter them down, we can actually attack these vulnerabilities that we know are critical and deployed on a public facing pod as well. And here we can see the actual evidence graph. Sometimes takes a while to load in, but if you give me a second, so we can see actually where that is deployed as well. Now, this is often useful for perhaps developers or security engineers who can say this is critical because it's on a live running instance and it's in the front end ingress there. So I can actually understand and now start to look at that vulnerability, assign that to somebody perhaps in Jira or fix it myself. But rather than looking at these 110, I'm going, these are the most critical ones for the running, the safe running of my application as well. So you can see that's a lot more powerful than just showing people a huge number of vulnerabilities. And often when we're compared with other tools, one of the first things they do is look at the number of vulnerabilities that each tool is showing them. We've seen it many times in static analysis, saying, oh, yes, you've shown us 20 vulnerabilities, but SonarQube showed us 312. And then the question is, but which ones of those are real? How are you actually fixing those vulnerabilities? How do you know they're not false positives and things like that? So here we're actually giving people evidence about why they should be fixing these vulnerabilities as well. And this even goes further as we go to launch our app risk. Now, this app risk is not yet launched, so I'm just giving you a quick preview here, which shows the kind of breakdown as to what we're showing you, which of your applications are covered by scanning of your whole environment, which are covered by different types of coverage, and we can go into lots more, but as it's not launched yet, and this is going on a public forum, I'm not going to show that today, if that's okay. As soon as it is launched, I'm happy to come and show you a lot more of this as we go in. Okay, so finally, what we've seen so far really is how a developer uses the platform. What we've also got at the top level is we understand security, compliance teams, infrastructure teams also need to use the platform. And this is really where we go to that top level, understanding the group or the set of projects that's below, looking at things like reports. Here we've got the issue report. This is a list of all the issues. Now we can filter this by, for instance, Snyk products. So let's just look at all the SAST vulnerabilities, anything that we've found in SAST in all of our projects and their relative score. Here you can see every time I change one of these filters as well, the URL changes and I can copy and share that to all of my friends or colleagues. Here you can see we can then filter by all of these things like project lifecycle, which ones are actually critical, which ones are live, which were part of my test. Exploit maturities, which exploits do we have within our infrastructure which people are actively looking for with scripts now? These script kiddies are everywhere, so we look at vulnerabilities by exploit maturity as well. On top of this, we also have kind of the issue summary report. Again, really important for noticing trends. how fast after vulnerabilities are detected are we removing them from the code base? Are we generally going down in the number of vulnerabilities we're finding in the project? And also over time, and you can see we're here on last 30 days, but I can actually change to any date range I want. And from this, how many have we resolved? Is it up or down from last week? Start to understand trends. Are people adopting the system? Are people using it? Are they finding value in it? And the exposure window. This is how soon after they're detected are we removing them? And that's that risk breakdown there. On top of that, again, SBOMs, understanding the dependencies, the licenses that are included in projects are very important, especially for people that build and ship software for other customers. Some customers might put part of their handover criteria, I want a full SBOM of everything that you've developed for me. What licenses are attributed to them, and then which vulnerabilities were in them at the stage that you ship this software. So Snyk allows you to create that full dependency tree, and we can even filter that down for particular vulnerability types of health of the project or particular projects as well. One thing that security teams really like is the policies side of things. Now, Snyk ships with very good license and security policies. So the license is around open source. And if you know commercial software, you'll know you don't want to ship software with any copyleft licenses. So the Snyk default license policy says anything that's copyleft, do not have in your software. We mark that as a high. Anything that can be interpreted as copyleft in terms of the license, we put as medium. That needs to be investigated because sometimes they can be permissive licenses. Then all of the good licenses, the Apaches, the BSDs, everything that we want is there as none. That's what we ship with. But we also allow you to create your own policies. Imagine you're building an internal application. You don't want to be held by false positives as you'd see them. So anything with internal applications, and here you can see I'm actually attaching this to projects by tag. So I'm looking at environment internal. Start looking at these projects and I can go and then change all of those to none because I don't care what licenses are included here. They're not part of our commercial offering. That's just an internal tool that we don't care too much about. Added to that, we've also got the security policies. Again, Snyk ships with a very good security policy, but I can go in there and add new rules. I can add new security policies as well for different projects. Again, this just allows us to configure what Snyk's showing people and ensuring that the developers are not getting what they'd see as false positives or undue noise from their projects as well. Okay, I think we've kind of given a bit of an overview there now. We can obviously go a lot deeper when we perhaps work as partners and enable the NFR for you. But are there any questions at the moment that I can help you with today? Stefan.
Yes, two questions. We've seen the Docker vulnerabilities. So for example, we've seen you had an image, I think it was Node 12, and
Yes.
then there was an upgrade suggestion to Node 21. Is it also possible to only suggest LTS versions maybe?
So long-term support versions, if we are not on the latest long-term support, you would have seen a minor upgrade there as well.
Okay.
I think in that instance, and I could be wrong, that we were already on the latest long-term support, and that's why it only offered a major upgrade. Let me just go back to the project and double check as well.
Mm-hmm.
We always do. Which project was it now? I think it was
Node Goof? Could it Node.js Goof or what?
No, that one was already.
It was a different one. Sorry.
Yeah,
yes.
Let's see here. Perhaps it was this one. So yes, so there is a major upgrade. So we would have minor upgrades, which would be still in the 12, but it could be that we're on the latest there. I don't see a 12 dot anything, but I'd have to go and check that one. But we do also offer, where possible, the minor upgrades as well.
Okay.
It could be that that has still got the same vulnerabilities, and that's why it's not offered, or there isn't another update to the LTS.
Mm-hmm. Okay,
yeah.
Thanks. And my second question was, how are runtime vulnerabilities linked maybe to repositories or to the project? How is it related to the Docker image that's running, or
So runtime vulnerabilities, that's where we work with our partners, Snyk. So when we're looking at containers, we integrate with Snyk, who can look at runtime vulnerabilities on the containers. We're all about composition, either the open source or the application that's running on that container as well. What we do is integrate with Snyk, who kind of inspect that container as it's running and can help us prioritize vulnerabilities further from that as well. Anything runtime or DAST, that's where we defer to our partners, because that's not what we want to do personally there ourselves. But absolutely, what we can do is perhaps set up another discussion where we bring Snyk on as well and show you about that full integration that we've got there.
Okay, great. Thanks a lot.
No problem.
Maybe to add on that one, Paul. So, like in our mindset, it's all about shifting left as far as possible, right? So enable the developer, right? Like writing securely. So like once we have a running application, which would then be Dust, that's not where we as a company position ourselves. So therefore we just do the SAST scans because this is the shift left approach, DevSecOps, what we want.